Okay, grade 10s, I'm going to give you a lesson. The video that's on the classroom right now is for solving triangles, right triangles, and I thought it was more just on the trig ratios, but I looked there today and it's a little bit more than what I want for the first couple of assignments. So I'll give you a lesson here on using just trig ratios to find either just a side or just an angle. So of course, from grade 9, we know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. You probably heard one of your earlier teachers call this Sohcahtoa or whatnot, but I like this one here better. Students of Hypotenuse can always help teachers on assignments. So that's the way I've always remembered. That's the way I always taught it. But here's the steps, anyways. Okay, we'll use these steps as we go along. So step 1 is you're going to name all the sides, either opposite, adjacent, or hypotenuse, from the important angle. Now I call the important angle either the one that you're trying to find, or the one you're given when you're trying to find a side. So if I'm looking for an angle, that's what I call the important angle. If I'm looking for a side, whatever angle's in the question, ignoring angle C or the right angle because you can never use that one, but whatever angle's in the question, that's my important angle at that time. Once you've named all your sides, then you got to figure out what trig ratio you can use based on the information. Now, usually it's only going to be one of the 3 trig ratios, unless you've got lots of information on there. And when you go to solve, that's when that happens. Okay, so it's going to be either sine, cos, or tan, not any one. Okay, you got to figure that out. Step 3, we're going to substitute the values into the trig ratio correctly. And then step 4, depending on what you're trying to find, whether it's an angle, like in example 1, or sides, like in example 2, with an angle, you got to remember you always second function the trig function. Okay, so you're going to get some decimal. That's not the angle. You have to get rid of the trig function to isolate the angle. So that's done by second function. And depending on the type of calculator you have, it'll depend if you hit second function first, then put in the decimal, or if you have the decimal in your calculator, if you hit second function, for instance, tan or cos, whatever it is. Okay, we'll see that when we get to the example. And then for sides, again, your unknown side can either be in the top or in the bottom, but it has to be in the top. We have to make sure it's in the top before we just do the math, whether we're multiplying by the trig ratio or dividing by the trig ratio. Again, we'll see that when we get to example 2. Okay, so there's your steps. Get them all written down, okay, because we're about to start the examples. Okay, so here's our example where we're going to go find an angle. We got this triangle, this right triangle labeled A, B, and C. We've got our sides. B equals 8, A equals 13. So, following step 1 says we're going to name all of our sides from our important angle. And our important angle is whatever angle, in this case, what we're looking for. So that, to me, is angle B. So from here, I'm going to name my sides. Of course, the side that's across from the angle is my opposite. The side that's beside it is the adjacent. And if you must, the longest side, or the side that's across from your 90 degree, is what we call the hypotenuse. Now that's all review from grade 9, so we can just, I'm going to make the assumption that you know how to name your sides. The hardest part, lots of people don't know where the adjacent is, so I kind of leave that to the end most times, because it's easy to see your opposite side, and it's easy to name your hypotenuse, so the default is that adjacent is whatever side's left over. Okay, so now, what trig ratio do we have to use here? Well, I'm given the opposite side, and I am given the adjacent side. So when I look at my 3 trig ratios, sine, cos, and tan, which one uses both the opposite and the adjacent? And some of you have probably already answered in your head that it's the tan trig ratio of angle B is equal to opposite over adjacent. All right, so now we're on to step 3 here where we substitute the values in. So the tan of angle B, and it doesn't matter if you put the theta in there if you want to. The theta is just like saying x, we're trying to solve for x, equals, the opposite is 8, there it is. So I'm going to put the 8 in, divided by the adjacent side, which is 13. Okay. All right, so when I go and I calculate this now, I'm going to put 8 divided by 13 into my calculator, and I get 0.615. Now in my calculator, I can just hit second function tan at this point because that's what's in my calculator. But some of you, if you got a different type of calculator, second function gets rid of the tangent function and gives us the angle, and you'll learn more about that later. Gives us 31.6 degrees. There's our answer. Okay, so that's about as much work as, it doesn't matter what trig ratio it is. Okay, so on another example, you might be using sine, you might be using cos, depending on the sides, but it's always going to change. Now, the thing that a lot of people don't realize is if I was asked to find angle A, let's pretend for a second I had to find angle A. Well, I would have to go and rename all my sides other than the hypotenuse. Hypotenuse always stays. But if it was to find angle A, then I'd have to name all my sides. This side over here is no longer the adjacent. It would now be the opposite. And the opposite would no longer be the opposite. It would be the adjacent. So again, depending on what angle you're naming your sides from, you gotta watch what's what. Okay, so it could change multiple times. Okay, let's go look at finding a side now. Okay, here's our side. Find side P question. We've got a triangle, right triangle, angle P, angle Q, and angle R. It's asking for side P. So again, we're going to name our sides from our important angle. So in my world, there is our important angle because it's given to us. I know that this one's the hypotenuse, always. I know that the side across would be the opposite, even though in this case it's not that important, like who cares. If I've got the opposite and the hypotenuse labeled, I know that side P is then by default my adjacent. Some people say, well, it's beside, and adjacent means beside, right? Angle 30 degrees. The hypotenuse is beside it as well, but the hypotenuse is a special side. Okay, so now, what trig ratio uses adjacent and hypotenuse? Cos of angle Q is adjacent over hypotenuse. Okay, so now I can substitute my values in again. I had to figure out what trig ratio. Well, because I'm looking for side P, which is adjacent, I'm given the hypotenuse, and that way I know that it's cos. So now I'll substitute the values in. So the cos of 30 degrees is equal to my adjacent, which is side P, over the hypotenuse, which is 24. Now you'll notice here that my unknown is already in the top, so that's beautiful. So I can just multiply this 24 across, and I get 24 times the cos of 30 degrees is equal to P. So when I put that into my calculator, what do I get here? I get 24 times, in my calculator, I hit 30 cos, but you might have to hit cos 30 first, and the answer comes out as P equals 20.8. So there's the side length of side P. Now, let's talk about a situation where if your unknown is in the bottom. So let's flip this around for a second here, and let's look at solving something like this. I'll just make a question up. Cos of 42 degrees is equal to 12 over, let's call it x, if my unknown's in the bottom. Now there's two ways of doing this. It doesn't really matter to me which way you do it, okay? I'll tell you the way I do it most often, okay? What I would do is I would multiply the x up and divide the cos 42 down. So I get x equals 12 divided by cos 42 degrees. And just put that in your calculator. Okay, now a lot of people would take this whole question though, and they would say, well, let's just flip the x over the 12, and the cos 42 would flip as well. And we know there's a 1 underneath it, so as long as you reciprocal both sides, now your unknown's in the top again. You can just multiply the 12, and you get 12 over cos 42 equals x. So when your unknown's in the top, it's easy because you just multiply the denominator up. But if your unknown's in the bottom, like in this question, you have to move that unknown so that it is in the top. So then you can go and solve this. And just to finish the question off, let's go put this into our calculator. 12 divided by the cos of 42. And you should have x equals 16.1 or so. Thereabouts. Either way you do it, okay?